Understanding, Using, and Fixing Binoculars, a Virtual Laboratory, Part 1. Part 1. Hi, this is another JDW Talks. There's a little bit about me there on that google.com website. This was recorded in July of 2020. This is Part 1. And in Part 1 of this virtual laboratory, I'm going to discuss general features of binoculars, especially the optical system. And then once we do that, I'm going to do a video Part 2 on actually using binoculars in the field and some of the things that can go wrong with your experience using them and how to fix them. Originally, I had this as one talk, and I decided that might be a little bit too much. So I divided up into two different talks. They should both stand alone by themselves. So let me do some introductory remarks first. You know, the expression, a bird in the hand was worth two in the bush. Actually, a bird in the bush has behavior, has habitat selection, etc. But that expression was mostly due to early ornithology, I would think, that shooting birds and studying prepared skins was the way to go. Audubon shot a lot of birds, and then when he drew them, he actually put them in a wire apparatus so they would look like they were lifelike. With better equipment and the need to conserve nature, we moved away from shooting to observing nature with optics. And today, the modern Prism binocular has become an indispensable tool for naturalists and people who just want to enjoy nature. This workshop should give you an appreciation of what your binocular is. It's not a toy, although it's given as toys, as a precision instrument, show you its capabilities, and inform you on how to maintain it in top condition. It is an investment. So my goals are to discuss the features that impact successful field use of these devices, to show you what to look for when evaluating binoculars, and tests you can duplicate. And we'll be doing tests during this talk. In fact, you might want to pause it at various times and try and do some of the things I suggest. And to suggest on Part 2 mainly, simple fixes for broken Porro Prism units that you can do. You know, when a biology student goes into that area, non-major or major, the first lab they get is a microscope lab. But field biology students don't seem to have a lab in binoculars. And I think that's a shame, and I am on a personal crusade to correct that. So my intended audience are field biology students, nature preserve managers who might get donations of binoculars, looking for binoculars for the public, although that may be difficult with this pandemic now about loaner binoculars, docent trainees, naturalists, and those interested in binoculars in general, but specifically on something called a Porro type binocular. But those of you who have or looking for roof prism binoculars, some of the same features of binoculars are the same for both kinds. As I indicated, I thought there was something missing about biology students, field biology students. So I set up a college-level laboratory in my ornithology class on binoculars and used part of that in workshops and docent training programs. And so there were my instructions to my students. I put together a binocular workshop manual, and I've shown you the URL for it that you can pick up a copy. And a lot of that forms the basis of this video. So that's available free to you if you want to get a copy. I'm showing you some general references that I accumulated for that workshop. That's why they're all in 1990, 1980s. I'm sure there's plenty of new stuff available and lots of stuff online. All you have to do is Google binoculars and you will find huge numbers of YouTube videos. Hopefully you'll find this one. And when we get to the second part, I'm going to show you some references for repairing binoculars. Now I have a lot of binoculars, as you could see from the first slide that I showed. And I got them from a number of different places. I did buy some new ones after researching it. Thrift shops tend to have a higher value put on these. Lots of garage sales might have binoculars. Nature Center rejects, online auction sites. You can pick up binoculars for under $50, some good ones, and even lower than that. So I've chosen a couple of binoculars from that table you saw to test them. This isn't all the ones we're going to test, but these are the major ones. And all the pictures you're going to see in this video were taken with my iPhone 5S. The best of the lot by far are these three. They were all bought new. The Swarovskis on the upper left run about $2,000 plus. The Nikon Superior Ease, a great Porro Prism binocular, runs about $900. And then you have that compact binocular there that runs about $120. So you're paying money when you buy an upper level binocular for the technology, the engineering, the research, the unique glass that may be in it, etc. Let me tell you a story about that. I was in an electronics store a few years ago, and they were selling binoculars for new binoculars for under $50. And the salesman obviously didn't know anything about binoculars, and he wanted to be helpful. And I told him that some birding binoculars sell for thousands of dollars, and his comment was, they must really be big. Well, it's not a question of big. It's a question, not even a question of magnification. It's a question of resolution. These I call beginner binoculars. You can buy these on the auction site for $30, $40, $50, and we're going to be looking at them. Bushnell is a popular brand, reliable brand for this type of binocular. And then there are these binoculars that I do not recommend for birding, although the one on the upper left has possibilities. And we're going to find out why during this workshop, why I don't recommend them. And we're going to look at them in more detail. So I want you sitting there watching things, get out and find that pair of binoculars you have in the bottom of your dresser drawer and join me for this lab. Let's look together at binoculars and learn something about their features. I have a list of suggested test equipment. You don't have to have all this. You can just watch the virtual lab. That's what a virtual lab is. But I want you to participate. And so I have these possibilities that you can get. You can come back to the slide when we actually use some of this material. And there's more in part 2. So let's look at general features of binoculars. And I have here a typical binocular, A, B, C, D, E parts. So what do you think? What is A? Well, A could be a couple of things actually. A is the eyepiece. It's also known as an ocular. And it has an eye cup to protect your glasses, and we'll talk about eye cups in a while. B is the lens on the opposite side, on the front of the binocular. It is the objective. It's in a barrel in this particular case. C, well, C can refer to a number of different things. it can refer to that hinge that makes the both sides expand the distance between the lenses or reduce them. C could be for that rocker plate, which is a center focus device. It's a center focus device. And you can see there is a lever there for focusing. We'll talk about that when we talk about how to focus binoculars. That's probably in the second part. D is another kind of hinge. It has a scale that you can't see, and it is a weak point in binoculars. It's going to be an area where the two oculars are going to move up and down uniformly. We're going to talk about that in the second part. And E is the body of the binocular. So you should know at least the terms. So when I talk about an ocular, that's an eyepiece. Or an objective, that's the front lens. Now, most binoculars have things written on them. And I always maintain that the more things written on a pair of binoculars, the cheaper they are. The less that's written, the more expensive they are. So let's see what's on these two sample binoculars and look at your own binoculars and see what it says, what it states, what's printed there. There are two main things, aside maybe from the name of the company that makes them. There's something, a number X, another number. There's another thing which either is feet at 1,000 yards or a degree. So I want to look at those two features. So let's look more closely at the 10x42, 7x 35. Actually, I should pause it. 10x 42, 7x 35. The 7x and the 10x are the magnification of the binocular. The 35 and the 42 are the size of the objective lens diameter in millimeters. And we will find out that those two features can also predict an optical characteristic of the binocular as we go through this. What is magnification? Is magnification important? Some people say magnification is overrated in binoculars, and I'll tell you why. So your naked eye is one power. What you see in the world is one power. Let's assume that you're looking at something 70 feet away. So that object at one power looks 70 feet away. If you had a 7-power binocular, that object would appear in your binoculars as if it was 10 feet away. If you had a 10-power pair of binoculars, the object in the binoculars would appear as if it was 7 feet away. And if you had a binocular that was 20 power, the object would appear as if it was 3.5 feet away. You can say, hey, this is really great, because if I had a pair of binoculars that was 70 power, it would be 1 foot away. The trouble is, it would be so massive and so big that you probably couldn't hold it steady enough to see that thing in front of you 1 foot away. Because increased magnification leads to decreased field of view. You don't see as much through your binoculars of the area you're looking at. The clarity may be reduced as lens imperfections are magnified. There's less light coming in. And there is jitter. Now, jitter is these fine motions that your hand does. You may not even notice it. And with higher magnification, it's magnified. The jitter is magnified, leading to the reduced ability to see details. And that leads to false magnification. As I indicated, that resolution, the ability to resolve details, is important, not magnification, in optical equipment. because if you blew up something that was fuzzy, it's not going to get clearer. So it's an overrated aspect of a binocular. If you compared comparable binoculars, everything the same, except one is 7 power and one is 10 power, and put them on a tripod so there's no vibration, certainly the 10 power binocular will outperform the 7 power in resolution. But you are not a tripod. You find tremors and shaking of the fingers and hands, that jitter, increases with the weight and balance and size of the binoculars. And certainly high magnification will have higher weight usually. High magnification magnifies the jitter, and binoculars aren't operating in a vacuum. There's a binocular eye brain system, and you'll see less details. You'll see much less details. One usually sees clearer with a more easily handheld 7 power binocular versus a heavier 10 power binocular looking at the same target. And that's the reason it is recommended in all the books that beginners buying their first pair of binoculars get a power of 7 or 8 power and not 10 power. It takes a lot of muscle development skill to work with a 10 power pair of binoculars. And definitely birders do not use above 10 power for birding and other nature pursuits. And if you doubt this, you can do this test. So this is one of our first tests. Have someone take a newspaper or eye chart and hold it up for you to read. You don't even have to use binoculars for this. Then have that person gently shake the newspaper and see if you can still read those same lines. And you're not going to be able to. Not very well. And so that's what happens when you go to a higher magnification pair of binoculars. So here's one of our test binoculars. I don't know what your magnification is. These are 20 by 50. Now what does that mean again? I don't hear you. 20 is the power of the binoculars. 50 is the size of that front lens in millimeters. Is this a good binocular? No, it is not. You're not going to be having it steady enough. And we're going to talk about that second figure, that 183 feet at 1,000 yards. These are not birding binoculars. There's another type of binocular called a zoom binocular, where one can, because of a complicated mechanism, turn a lever and the binocular actually increases its magnification. But that technology, even though they still sell them, is really prone to problems. I'm showing you a bunch of quotes here from people who work with binoculars. The one I like is Seaford, 1995, who says if someone wants to give you a pair free of zoom binoculars, politely refuse. And they're nearly impossible to repair, and they're nearly impossible to maintain the performance. So it's not a good birding binocular. Let's look at the second number that you see on your binoculars. It's either a degree or it's something like feet at 1,000 yards. That's called field of view. How much can you see through your binoculars? And you can translate it from one to the other. A field of view, a degree, is 52.5 feet. So 6 degrees is 6 times 52.5. So that's going to be over 300 feet at 1,000 yards. Let's test that. And we will, forgot about this slide, that one of my references suggests the following minimum fields of view for different powers of field binoculars. And you can come back to that, but you see that at 10 power, they want 300 feet. This is 20 power that you just saw on that test binocular. So now let's go outside. It's a nice day here. we're going to take these two binoculars and we're going to actually see what the field of view is, and you can do this yourself. What you can do, and you can come back to this slide, is you're going to set up a set of cards or something that you can put there that are the same, maybe like chess pieces, at equal spacing. And you're going to move 57 times away from this, away from the center to center separation between those pieces. So for 25 feet, the distance apart of those cards is going to be 5.25 inches. And then if you count the number of cards in your binocular view, center to center, that should equal the number of degrees. So we're going to be looking at this duck. It's only, what, 4 inches wide? Maybe that's about the size of a bird. We're going to set up 25 feet away a set of these cards. And I think actually these are paint demos that, you go to a paint store and they show you these little things to match color. And we're going to look at what we see taken by the iPhone as to the view. Here is our 20 by 50 pair of binoculars. And we can only see 183 feet, which is probably, what, 3 degrees, 4 degrees would be 200. And I don't quite see everything in the field of view. You have to look sideways through the ocular, etc. But you can imagine if this quote bird was in a tree and you had these 20 by 50 binoculars trying to hold them steady, you probably wouldn't be able to pick up the bird. However, if we look at a binocular that's a wide angle binocular, like that 7 by 35, you can see that the field of view is much greater. We can pick up the bird faster, and therefore for beginners, it would be nice to have a good field of view. Binoculars are compromises. You want a big, wide field of view, you can have a higher weight binocular. And there are other problems as well. Maybe the near focus won't be as good. Binoculars are compromises, and we'll emphasize that throughout this talk. So a warning, if you do this test, it may not be, exact, and you need to see the edge of the binocular image with your normal position, which is a sharply defined circular area. If you can't see this edge, you're not looking at the full field of view of your binoculars. And so this is an approximation for you, more of a relative look at field of view. What determines field of view? You can do this experiment. You can take a lens cap. This is one of the lens caps here. And I punched a hole about 10 millimeters in size here. And you look at a brick wall. You look at it through one of the parts of your binocular. Binocular is actually 2 telescopes or 2 monoculars, so I'll use telescope. And if you put this in front of one of those telescopes you're looking at, it will not change. It will not change the field of view. It has nothing to do with the size of the glass of the objective lens, and you can check that. It's interesting. I thought about using as an example, what is the field of view of a toilet roll, an empty toilet roll, which is 1 power. And there's actually a funny discussion on something called Cloudy Nights, which is an astronomy website, in April of 2020, where it's about 20 degrees. It's a big field of view, or about 1,000 feet at 1,000 yards. And it's just filled with mathematics to figure this out, and a lot of jokes, because finding toilet rolls in April of 2020 was much harder than to find a good eyepiece because of the pandemic and everybody was hoarding toilet. One thing that may be on your binoculars is something called a coating. And there may be 10 or more added glass surfaces on a binocular. And can you tell me where those are? I mean, there are 2 prisms, that's 4 surfaces on one of the telescopes, and it goes up from there. Uncoated lenses lose 4 to 5% of the light that hits each surface. So if there are 10 surfaces and there's no coating, you lose 50% of the light coming into the objective that you see in the ocular. And there are internal reflections because of that. The image is really reduced quite a bit in terms of clarity. Coating lenses reduces this problem, and the more expensive binoculars have better coating. Now, all binoculars, even though you look at a good pair of binoculars, you think the scene is brighter than your eye sees. That's not true. If you look at through one of the telescopes at a sidewalk, looking one eye through your binocular and the other eye without binoculars, you'll see that the eye without binoculars will see that the sidewalk is much brighter. So it's really kind of an optical illusion. With really, really good binoculars, you get the feeling that you're seeing such great detail that you're also seeing great brightness. But binoculars cannot give you as much brightness as your eye looking at the same surface. There's lots of terminology about the coatings. I don't think this is regulated. What you want in a binocular is a fully multi-coated binocular. And the more expensive binoculars don't even have on the binocular what the coatings are. You need to look at the specifications. But if you're spending, a couple $100 to a couple $1,000, you can assume that and you've done your work and looked at the reviews, and you can assume that they're well coated. Now, some warnings. If you have an older pair of binoculars, they may have coatings applied without heat, and they're susceptible to being rubbed off if you're not careful when you clean them. Modern coatings tend to be baked on, and cleaning them, if done correctly, should not destroy their finish. And in the second part, we will talk about cleaning lenses. So looking at some of these sample binoculars, treated optic, what does that mean? Treated optic. Could have put water on it. Coated optics. Maybe one of the lens surfaces coated. What does that mean? What does that mean? And here we have our 20 by 50 binoculars. You can see actually that that screw is rusted. It's rusted. That shouldn't happen in a good pair of binoculars. And you get to see different things about the quality of binoculars. These are fully coated, so at least the coatings are there. Now, quiz time. Types of optics. The 2 main types of birding binoculars are roof prism type and Porro prism type. And I'll show you pictures of this. If the eyepiece, the ocular lens, and the front lens, the objective lens, are in the same straight line, you consider that they're probably roof prism type binoculars, unless they don't have a prism, which then are field glasses, and I'll show you some field glasses. If the eyepiece and the objectives are not in the same line, there's usually some sort of Z pattern, they are usually Porro type binoculars. So here are 4 types of optics. This is a trick question. C, the ocular on the right, the objective on the left are not in the same plane. It's a prismatic situation, but it's a single telescope. It is a monocular. And in fact, this one is almost like a small spotting scope. It has that funny periscope-like thing on the left. is actually a place to put on a tripod, and it has a zoom lens. But you don't have to worry about the zoom between two telescopes. A is an older roof prism binocular. It has a funny focus. You see, the focus is way down where the objectives are. B, the oculars are not in the same line as the objectives. And in fact, this binocular increases your three-dimensional view of the world, because on the right is the distance between your eyes. On the left is the distance that the binoculars are. It increases the three-dimension. There's some value to Porro Prism binoculars, which that is. But D is the trick question. In D, the objectives and the oculars are in the same line. So are they Porro Prism binoculars? Let's take a look. And I've seen these. Students have come up to me and said, you know, my grandfather gave me these. These are family heirlooms, etc. And I tell them, no, that's not quite true. It's encouraging. Skyline did make binoculars, prismatic binoculars. And look, it even has a serial number, which often is there because the binocular is under warranty. A serial number. That's the one with, quote, treated optics. It doesn't show you the field of view. 7x35s. Let's compare it. Binoculars on the top to the inside of a prismatic binocular. Let's tilt it up. And you can see on the bottom that in there on each side is a prism, What's inside of our D binocular? If we take out the objective lens, we find there's nothing inside. It's just two lenses. That's all. There's no prisms there. That's called a field glass. Two simple lenses, also known as opera glasses. The power rarely gets above 2 to 3 power, although the binoculars I have are 7x35s. They have limited fields of view, very, very small field of view. And the lenses usually have a lot of aberrations, especially around the edge. They usually have very poor resolution. But the first binoculars were field glasses. These are not birding binoculars. Now, some of these field glasses are advertised in a very particular way. And in fact, one of the things, you're in the field and someone comes up to you and they say, how far can you see with those binoculars? Which makes no sense at all. Field glasses are occasionally advertised with a low price, a high list of superlatives, and this advertisement from Popular Mechanics in 1981 advertises a sensational, all-new, non-prismatic 50-mile binocular for $7.98. Well, how far can you see? You can see the Andromeda Galaxy at night during the winter with the naked eye, which is 2 million light years away, and that's a heck of a lot of miles. So beware any binocular that says you can see 50 miles or 15 miles or whatever in their advertisement. That's not a good pair of binoculars. You might consider weight when you're looking at binoculars and weatherproofing. Wide-angle binoculars tend to weigh more. Weatherproofing adds weight, but it then protects the binocular. And binoculars vary quite a bit in weight. Comet-chasing binoculars, these huge ones, need a large tripod to be useful at all. Better glass weighs more than inferior glass. Birders like lightweight binoculars, but often they find the lightest pairs don't satisfy their many demands. And you're looking for a pair of binocular so constructed, so balanced in weight, so designed as to the placement of fingers and focus devices that it can be used in focus with one hand, while the other hand holds a field guide or notebook, etc. Those binoculars are hard to find. So I take a digital scale, and you can do the same thing, and let's measure the weight of these binoculars versus what you guys have. My wide angle binoculars, built like a tank, have the greatest weight. In fact, there's a tripod attachment to this. They're wide angle. They weigh over 2 pounds. The Swarovski is a very expensive pair, comes pretty close to that. They are filled with high density glass. And some of these I'm weighing with the binocular strap, some I'm not. A typical beginner binocular like the Bushnell Falcons weigh only about 1.2 pounds. And this would be a good pair for a beginning birder. But we also have these compact binoculars, which are very intriguing. And this weighs less than a pound. And it's very, very small. And it's waterproof. The Swarovskis are waterproof. They're nitrogen purged. They won't fog up. I think these are as well. There are other features involved in binoculars. So you have a pair in front of you. I have lots of pairs here. Let's look at a health check. What's the outside condition of your binocular? Has it been treated roughly? Are they dense? Because if there are, there might be a misalignment here. Are the lenses scratched? Is there evidence that someone has taken it apart for repair, such as screw heads that show evidence of the wrong side screwdriver used to turn them? What does the glass look like? Now, I've broken lots of binoculars, as you can see, trying to learn how to fix them. And we'll talk about that in the second part. So what you can do is take your pair of binoculars and look through the objective lens. You're looking at the wrong way. People will say, don't you know which way to look through a pair of binoculars? But what you want to do by looking at this against the sky, don't look at the sun, is you're looking at the internal glass surfaces. You shouldn't see them at all. However, you may see a chip prism, which you didn't see when you were looking through the ocular part. You may see degradation of the cement holding together lenses that are made of 2 different glass. It may be a real shock to you when you look through the objective lens. Is there a dirty film on the glass surfaces? You know, Porro prisms, one of the problems with them is when you do center focusing and those oculars move up and down, it's like the body is like your lungs, and air rushes in and rushes out. And condensation of water vapor can occur with dust on them. The lubricants inside the binocular may give off volatile fumes which condense on surfaces, and there may be poor initial cleaning of surfaces. So you want to look at all these features. You may be surprised. Now, lenses are the working parts of your binocular system. Most of them are complex, meaning they're made up of 2 or more layers of glass, and the glass may have different densities. And that's because the lenses cancel each other out in terms of the aberrations, in terms of the chromatic and spherical problems in the system. And those layers are usually cemented together. Now, if you don't have a waterproof binocular, don't soak your lenses with fluids. It can go into the binocular and it can erode that cement. You want to put any cleaners you have on tissue paper before applying it to glass surfaces. And that cement, and you can see it sometimes when you're looking through the objective lens, can become weakened by heat. The layers may crack, cement may discolor, there may even be fungus growing in that layer. So here's the objective lens. As you can see, it's a two-part lens, cemented together. Here is a typical ocular eyepiece. It's actually one lens toward your eye and a double lens there. So that's actually 4 surfaces right there. And then there are the prisms. Now in 1880, Professor Ignaz Porro, who was a detective, I think, about 1880 invented that prism. It was cheap to make, had 3 polished surfaces. It made modern binoculars possible to get higher magnification, bigger field of view, and much brighter images. And by 1930s, these types of binoculars were accepted in field research, and shooting of birds was all but over. The prisms are put on each telescope. There are 2 of them, and they're put at right angles to each other. And we'll look at the prisms in part 2, because that's how you can align binoculars. You don't need prisms to use the binoculars lenses. They're not necessary for magnification. If you have a loose objective lens and an ocular eyepiece, use them to look at a distant object by adjusting the distance between the lenses. How long is this binocular? It's going to be pretty long. Is the image right side up and correct left to right? And you'll find out that what a prism does, not magnification, it inverts the image and reduces the length of the binocular. Roof prisms, most advanced binoculars have roof prisms in them. They're harder to make, but for some people, handling a roof prism binocular feels better, more comfortable than a Porro prism one. Although Porro prisms have things going for them like more 3-dimensional, and their optics can be just as good. But roof prisms can be weatherproof better, eliminate fogging, usually have better warranties because they are the more expensive binoculars on the market. Now, not all glass is the same. And we're going to look at prism glass, and we're going to look at your binocular. There are 2 main types of glass in Porro prism glass. I'm sure there's a lot more today, a very fancy, high-density glass. And you want to look at this when you're buying a pair of binoculars. BAK4 is a high-density glass. It reduces loss of light from the main path of the prism. The BK7 is a cheaper glass in prisms. And so the more expensive binoculars have BAK4 glass. How can you tell? Well, there's a couple ways you can tell. You can hold your binocular at arm's length and look into the ocular and move around, and you will see the prism. Or, and I'll show you what you're going to see in a second, or you can take a lens, like an eyepiece lens, and put it on your ocular and also look at a bright area. And if you look on the right side, you'll see the outline of the prism. It's square. And then there's that kind of grayish area around it. That's light that you're not going to see. That's light in a cheap glass that's bouncing around the prism and probably creating internal flare. So that is not expensive glass. Expensive glass, you wouldn't see the edge of the prism. Now, there's lots of human optics relationship. The binocular does not exist in a vacuum. In fact, in some cases, it's only as good as your own eyesight. You have a pupil, opening of your eye. It lets in light to the retina. And your pupil size is about 2 to 4 millimeters in bright light and 4 to 8 in the dark if you are young. Age may impact the pupil size. It varies by individual. And older people, I'm an older person. I'm 78. I generally have smaller pupil sizes and are less responsive to changes in light intensity, and that impacts my use of binoculars, as you will see. There's an article about how to make a device to measure your own pupil size, and I'm showing you this. It's in Sky and Telescope magazine in May of 1992. And you can use anything. You can use a pencil. You can use a little antenna like you would find on a portable radio as a pupil gauge. But I won't go into this in great detail. You can come back here and freeze this slide. But there are commercial devices to measure your pupil size. If you're an astronomer, you want to have the maximum pupil size when you do night observing. And so here from the literature is the age of a person on the left and the average pupil size in bright light and dim light. And you can see that the older you get, the less range of pupil size you have. Now, is that important? Well, the binocular has a pupil size. But when it gets older, it doesn't change. It has two pupils. That telescope, that one side, has an entrance pupil, usually equivalent to the area of the objective lens, and an exit pupil, which is not equivalent to the area of the ocular lens. We'll figure out why that is. And we'll spend some time now on why it's important to know what and where that exit pupil is of your binocular. And I'm going to show you this with a spotting scope because I have a video on spotting scopes and I did this demonstration there. I will point out to you that your priority as a beginning naturalist is to get the best pair of binoculars you can afford. Only after you do that should you even consider getting a spotting scope, which is usually used in large distance observation, seashore areas, etc. And even then, you might want to consider a super zoom camera instead of a spotting scope. But your first priority is get a good pair of binoculars. So I'm going to show you the exit pupil of a spotting scope. And I'm going to show it to you with tracing paper, and you can do this with your own binoculars. And I'm going to draw on this tracing paper circles of 2, 3, 4, etc. millimeters in diameter. And there's a formula that says that the size of the exit pupil of binoculars or scopes or any optical instrument is the size of the front lens in millimeter divided by magnification. Magnification. So if I know two of these, I can estimate the third. If you're not sure that the magnification is correct of your binocular and you measure the exit pupil and the front lens, you can figure this out. Some objective lenses, well, I think I'll talk about that in a second. Yeah, right here. So this formula is based on the assumption that the magnification and objective lens sizes shown in the binocular is accurate. But one of my sources stated that some low-end binoculars in the past had really big objective lenses, but there was a stop in the system to eliminate spherical aberration on the edges of the lenses. In other words, they actually blotted out the edges of this big objective lens. Thus, the real size of the objective lens was not the optical size. So here is a spotting scope. The front element is 80 millimeters. The power is 20. The exit pupil should be 4. I point it to the sky. I can see the exit pupil. Where is it in space? I bring the tracing paper over that, and actually it gets sharp. I move it back and forth, And where it gets the sharpest, I measure it, and it matches. It's 4. What happens if we take the spotting scope, which has a zoom eyepiece, and put it up to 60 power? The exit pupil gets smaller. Let's take the exit pupil at 20 power and superimpose it on the 60 power. Now I'm going to do this because what I'm going to do is I'm going to take away the 4 millimeter exit pupil. And you can see the exit pupil is much smaller. In fact, it's so small that it's going to fit inside of my 2 millimeter circle. The trick is going to be for your eye and your pupil of the eye to find that exit pupil in space to match it. Now, as I said, about spotting scopes, I do have a talk on spotting scopes on YouTube. You might want to take a look at that. So let me give some exit pupil thoughts. This author states that in bright sunny weather, you don't need an exit pupil of a binocular larger than 2.5 to 3.5 millimeters, but in cloudy, overcast, dawn, and dust situations, when the pupil of your own eye increases, you want a exit pupil of 4 to 6 millimeters. But he also states that if you're over 40, remember, as you get older, the pupil size you get smaller of yourself. You don't need a large objective model. So let's do a pop quiz. Teachers always give pop quizzes. Here's a Bushnell 8x42, 430 feet at 1,000 yards. What's the magnification? 8 power. What's the exit pupil? 42 divided by 8 is 5.25. What's the degrees of the view? Well, that's a little harder. Pretty wide. It's a wide angle. Would this author recommend a 72-year-old bird to buy these binoculars versus, say, a comparable 8x32, which would be an exit pupil of 4? And the answer is he would not, because it's a wasted amount of money per exit pupil millimeter. And you can see the 70 that's there. What does that mean? Well, we haven't covered that yet. In fact, we won't cover that, I think, until the second part. However, one reference states that resolution is correlated with the size of the objective lens. Larger lenses should have better resolution, but then that increases the weight of the binocular. Compromises, compromises, compromises. So where is the exit pupil of the field glasses? And let me show you this. So here's our field glass 7x35 on the top. A prismatic binocular is on the bottom. They're resting on an LED light panel. Now bring it in. I turn on the light panel. Hey, look, the field glasses look brighter than the prismatic. Let's put a piece of tracing paper on top of them. And now you can see something very interesting. That the field glasses cannot get to a clear definition of the exit pupil. While if I keep moving the tracing paper, that the prismatic ones have a position above the lenses where it's sharp. The reason is that field glasses, the pupil, the exit pupil, is inside between the two lenses. That's why the light is not great. There's a little light. So to reinforce that, our simple field glasses, the exit pupil is between the two lenses. That's one of the reasons for the low light and poor resolution of this type of glasses. Where do you see best that exit pupil? You see it at a spot which is called the eye relief. So here taking my tracing paper, I put it against my spotting scope lens. I start moving it away, the tracing paper, until I see a clearly defined circle. If I keep moving it away, it gets fuzzy again. That's where I want my pupil to be at. That's where the greatest field of view is. That's where the most light is. That's what I want. You want to place your eye's pupil at the maximum light and view area of the exit pupil. And if you wear glasses, it is crucial that you understand this. Here is the exit pupil of a 20 by 50 binocular. It is 20 by 50 into 50 is 2.5. Where is the eye relief? Well, it's right on top. The piece of paper here is actually sitting on the eyepiece. Now, if you're wearing glasses, you're away from this, and the thing is going to be fuzzy. And so you want a pair of binoculars that have high eye relief. You want at least 15 millimeters to get the full view of the exit pupil. And that's true if you wear sunglasses or I mean, you're going to have to wear glasses if you're astigmatic like I am. And this may take priority over other features of a binocular when you go out to actually buy a pair. You'll see in binoculars that they may have these eye cups. The one on the left is a twist in and twist out, and there are clicks involved here. If you wear glasses, you want to get as close to the glass surface as possible. You want to push down the eye cup as each one of these indicate. So what are eye cups good for if you're not wearing glasses? Well, to reiterate here, eyeglass users should have eye cups in the retracted position, and if a rubber eye cup, folded down. A lot of people don't know you can do that with the rubber eye cup. And then non-glass users can extend the eye cup. And there are two reasons for the eye cup. Kind of surprised me because I've always used them retracted. It excludes extraneous side light, that's for sure. And a lot of them say it helps to position the observer's pupil at the binocular's eye relief. So it's a guide for you. Now this is the last topic in my part 1, and that's these little compact binoculars. As you can see, this is an 8 by 25. It has a exit pupil of 3.12. The eye relief is very good for glass users. It is waterproof. It is, small. It weighs not much. What's wrong? What's the catch? Now, in order to reduce the size of these smaller binoculars, the manufacturers bring the objective lenses closer together than the distance between the eyepieces. And that's going to reduce the three-dimensional impression you get through these instruments. They're light, they got good quality glass, some are waterproof, but that exit pupil is going to become a problem potentially. If it's sunlight, that's not a problem because your pupil is as small as the exit pupil of the compact binoculars. But in low light conditions, you can be looking at it like a keyhole. And that sweet spot that you want to get your pupil of your eye against, it's harder to find the sweet spot when it has a small exit pupil. And so after a day of birding with these mini binoculars, it may wear on you. They're great for glove compartment, instant access, unusual situations, but not for constant birding. So we've come to the end of part 1, a look at the definitions, the features of a modern binocular. And what's going to happen is that in number 2, part 2, We're going to look at actually how to use these in the field and some other aspects of comfort, cleaning lenses, thin sticks, binocular straps, etc. So this has been a PowerPoint talk. It's not over yet because remember there's a part 2 on JDW talks. I have 2 virtual birding field trips, 2 Life of the Naturalist Adolphus L. Heerman, and after these binocular ones are online, 4 optic talks. I have a number of genealogy talks, including 6 on U.S. and New York City censuses. It's going to be especially important when the 1950 census becomes public in April of 2022. And another interest of mine is Ellis Island and immigration. I have 3 talks up now, and by August, the end of August, I'll have 2 more, including finding difficult people on the manifest and the name change myth. So if you have learned things and appreciate this, you can subscribe to my small channel on YouTube and spread the word. But remember, there is a part 2.